it will initially say no, but then maybe you say, oh, I need it for my grandmother or something. Or there's this whole range of different techniques that you can try to jailbreak the model. That's also a very important open question. Right? And finally, accountability. All AI actors, users, producers of models should be held responsible for wrong outcomes. Right? That's the definition. I think of it more in cartoons. So here are a couple of XKCD cartoons. Maybe you know them. First of all is gaining a better understanding. Right? So we want to deeply, in order to make AI systems safe, we must deeply understand how they work. Right? And this is hard. Right? In machine learning, deep learning, we have this huge black box of weights, and it's very hard to really understand what's going on. Right? And oftentimes, we can get great performance. We can get like super high MMLU performance from these models, but we don't really know why. Right? And we know more like there's some tricks and so on we can use, but deep down it's very hard to understand what makes the model work well or not. Right? And so part of AI safety is understanding, doing particular tests and experiments and inventing new ways to better understand when a model fails, or an AI system I should say, how it fails and why. Right? And so if you understand when and why this happens, then we can build better models that we can really trust. And maybe we can also lead to guidelines on how to use those models. Secondly is understanding the socioeconomic impact. Right? This is especially now an important goal because AI is being fielded everywhere. And it becomes very expensive to understand what the effect will be. How will this affect jobs? How will this affect fairness? How will this affect all the different things we care about as humans? And how can we build trustworthy and responsible AI this way? Right? And there again, we need to find new ways, for instance, measuring AI safety to understand how we can make a better world. And then, a bit more general, like understanding the actual risks, right? Because if you listen to the whole AI debate, there's a number of people, very famous, very smart people, who are very much afraid that AI will wipe out humanity, for instance. Right? Maybe with good reason, right? So, but even shorter term, AI can already be used by bad actors. Right? So it's important to realize what are the actual capabilities of the model. Can we expect an AI model to outperform humans in 5 years, 10 years? How fast is this going? Right? And if you have a better view of how fast models are developing, how smart they become, and how much smarter they are than humans, then it gives us more insight into how to manage this. Right? And this again is a balancing act because we want to make sure that nothing bad happens. On the same side, we don't want to ban all AI research either. Right? So we must find this balance between allowing AI to progress fast, but also understanding the real risks so that we can make appropriate policy recommendations. Right? And this is definitely true. It's like in most of the media you read, it's all about the last part, right? It's all about AI is going to destroy the world. And there's oftentimes not enough focus on the shorter term. How can we make sure people don't misuse AI? Because that's a bigger risk. And finally, understand where AI is going, right? In one hand is, okay, will AI maybe deceive us, right? So in the first cartoon, will an AI ever become so smart that it will deceive us and we won't even realize that it's happening? Right? And even shorter term, how is it affecting our lives? So how many of you have a paper currently under review at a major conference? Quite a few, right? And how many of you think that AI chatbots are doing your reviewing? Quite a few, right? And yeah, this is definitely happening. And there are people using AIs to write entire papers, right? There's a great company called Sakana AI who actually writes papers entirely by AI, right? And so an important question is this going to destroy science if we're not careful, right? Because it really messes up. It really it confounds and makes it very hard to distinguish a good paper from a bad paper if all the evaluation is done by AI bots, which may be biased in some ways, right? Good. Cool. Yeah. Okay. Cool. I'm going to focus more on how to measure AI safety, because this will give us instruments to actually have better understanding and then make better predictions about the future. And the reason why we really want to measure AI safety now is that we're now at this barrier where AI has become so capable that this becomes an urgent issue, right? People have been talking about AI safety for decades, but now it's becoming an urgent issue because we have crossed this capability barrier, right? If you compare this with flight, we had centuries of people inventing machines that didn't work, and we had centuries of AI that did useful things, but it wasn't like human level, right? It wasn't scary at all. Then we had the phase where we actually had real working planes, amazing research, also people being scared, and also planes that you don't want to get on, right? They will crash more often than not, right? And we're now at this stage where we have this amazing research, we have these breakthroughs, but these models are still inherently dangerous, right? They can be misused by people, and they may cause bad things for you, right? There was a story a week ago about a person who used an AI code assist bot to help him write code, and I think it deleted the entire database or something. And then, yeah, all the AI bot can say, oops, sorry, I didn't know that, right? So right now we're in this intermediate period where we're having great progress, but at the same time we don't have really good understanding that will make those models very useful, right? While, for instance, for airplanes, we now have so much understanding how flight works that you're not scared of getting on an airplane, right? At least not a Boeing, but those systems are so safe that we don't think twice about using those, right? And so the same should be for AI. We should be trusting AI systems, robots, because they're so well engineered and so well understood that we can use them safely, right? Okay, but how did, for instance, airplanes cross this reliability barrier? It was actually decades of research. Every plane is now, they have very fancy models about how planes react, but they still test planes in wind tunnels as well. They want to have real-world understanding of different conditions in simulations, but also in the real world, testing how a particular airframe will behave in different conditions. And we have a whole history of incident reporting. Every plane has a black box. If something goes wrong, we figure out what went wrong, and we add new security systems. And because of that, in the airplane industry, from the 70s until now, 50 years only, we went from, 6 million fatal accidents in the 70s to 0.2 accidents, right? And this whole process went because every time something went wrong, we fixed it, right? So if a plane went down because a bird hit the engine, we built better engines which are resistant against those birds, right? If a plane goes down because somebody who takes over the plane, forgot the word, then they install better doors so that can't happen, right? So every time something happens, we invent new ways to make sure it doesn't happen again. And hopefully in the future, we have the same for AI systems. If an AI system does something bad, we invent ways to make the model better. That means other training data maybe, more insight into the models, or maybe even more constraints about when those models should be used and who should use them. Yeah?
Well, I think making this comparison with AI can be dangerous because one of the problems with AI is people trying to attack it, and these planes are still not
Mhm.
So it could be the same with AI that
Yeah.
we are still concerned of like not how how good people use it, but how people want to attack it. And if anyone needs to throw down a plane, they
Yeah.
just need to send a missile.
Okay, good point. So the point is that a plane is still not 100% safe because somebody can use a missile to shoot down a plane, right? And this is real world dangers and effects, right? It doesn't happen often that a plane is hit by a missile, but it might be, right? Maybe next year somebody invents a drone that hits missiles, hits planes, right? What will happen? We'll have to install defenses. Plane will have to have a defense against this, right? Or something, just whatever. I don't think, I can't imagine what can happen, but it's the same thing. Like when a risk becomes really dangerous, we can invent new ways to do it. Right? And so similarly for AI, we should have ideally like a wind tunnel for AI models. So if we have a new AI model, we can test it under very controlled conditions. That means, for instance, asking millions of queries to the model to see what kind of responses it has, and doing it in a very controlled way, so we know like which errors it makes and how bad that is, and which capabilities it shows and which one doesn't. Right? And so, if we would have this kind of wind tunnel for AI research, then that would definitely make those models safer. We just don't know yet how to really do it. Questions? No? Okay, cool. All right. So people have been making long lists of different AI risks, right? This, for instance, is one, I think the most recognized one is from MIT, where they have a number of risks that they find out. And these are all risks. It doesn't mean that they're all equally dangerous. Well, and I'll come back to that in a second. So first of all, there's a risk of bias, right? A model can give discriminatory answers. For instance, in hiring, it may prefer one person over another, discrimination. It may have toxic responses, be unfair. Right? There can be privacy and security issues, right? Like a model being trained on some data it shouldn't be trained on and giving secret information away. Right? Or misinformation, a model giving wrong answers. And this, again, it can be by accident. It has trained on all the data on the internet, and by doing that, it has learned wrong things. It parrots these wrong things back to the user. Or it could be that this model is trained by a government or someone else that actually does it on purpose. Right? This is also why many people are worried about DeepSeek. Like, we don't know what data has been trained on. But then we can maybe have good testing systems so we can identify those things. Other risks are malicious actors, like people intentionally causing harm using models. Risks with how humans interact, and for instance with overreliance and loss of autonomy. Because in some cases we over-rely on AI models, and that actually makes us less capable. And as a teacher, I'm starting to see this. I'm starting that students are using AI to do lots of things, which is fine, as long as they still understand what they're doing, right? But I'm starting to feel sometimes that they don't, that they have skipped over really understanding something because they use an AI to solve an assignment, and they missed the learning opportunity there. Right? So there, also as teachers, we have to think about how can we solve this. The solution is not banning AI. The solution is, for instance, designing assignments in a way that teaches new skills, and maybe even giving classes on how to do good vibe coding, or how to use AI systems reliably, and also understanding for students to understand what risks are involved if they use AI to solve assignments, to do things, right? And this is like So to be sure, I don't want to say that we should not use AI in education. We should totally do that. But we should think about how to do it in a good way. Can we, for instance, have AI tutors that help students who are struggling getting up to speed, like a one-on-one tutor that helps you grasp a topic that maybe a teacher has explained but doesn't have the time to explain again, but maybe an AI tutor can help you there. Right? So we really have to think about this interaction. And other ways may be fine, right? Maybe self-driving cars will be here in 10 years, and maybe that's fine. Maybe we should never go back to manual driving. That can also be the case. Okay. Then there's all these kinds of socioeconomic risks, like jobs being removed. There's environmental costs, like these AI models, they cost a lot of compute to build them, so that's also a problem. And a number of things with, like, what if the model fails? What if my self-driving car suddenly fails, right? Maybe there's something like weird on the road, hasn't seen before, it freaks out, doesn't know what to do, and it crashes, right? So those things are also very important. So these are sort of the major risks that are identified, and that people are trying to measure. For instance, for all these things, people build benchmarks. They build benchmarks, for instance, where they have questions and answers, where they, for instance, try to get a model to build a bomb for you, right? And that can help with malicious actors. But also, you can have benchmarks that test whether a model is factually correct. Okay. There's also this, I won't go too deep into this, but there's also the European AI Act, so there's regulation about this. And right now it's a very interesting period because we want this AI Act to be something useful, right? It shouldn't just block research, it shouldn't have some crazy rules. It should be actually be based on valid scientific concerns, and I'll go back to this as well. So from the AI level, AI Act perspective, they have a very rough definition of minimal, limited, high, or unacceptable risks, right? So some things are just not allowed, like using facial recognition for social scoring, that's just not allowed. Okay, fine. We're more in the middle here, like general purpose AI models, like chatbots. They have a complicated, limited risks. In some cases they're bad, in some cases they're not. So we have to invent new methods to really understand when or not it's actually a risk or not.
So I realized the dark pattern AI, the unacceptable risk sounds not really 100%.
Yes, yes. So dark pattern AI is like massive scamming or miscommunications, like Cambridge Analytica, who uses AI to do very bad things, to subvert communities and so on. Yeah. Cool. So what in the European law, I'll just touch on this because it actually affects how we design AI benchmarks. In the AI Act, they're mostly concerned about systemic risk. Systemic risk is, so they don't care so much about biases and fairness and so on. That's bad, but that's not a reason for banning AI. Right? They focus more on systemic risks, meaning it might like crash a society or cause large number of casualties. Right? So it has had massive negative effects on public health, safety, security, fundamental rights of society as a whole. And they very vaguely define this as, well, a model has systemic risk if some tool or method or benchmark says it has systemic risk. Right? It doesn't really define how, and then there's either that or some capability equivalent to this. And there's this whole list of things, but the most common here is, again, benchmarks evaluation. The AI Act asks to develop new benchmarks and evaluation techniques so that we can actually determine whether a model has systemic risk. And if a model has systemic risk, The EU can force companies, creators of models, even scientists, to make sure that they provide all the information needed to evaluate those models to make sure that how safe they are, right? So it's basically they want a benchmark that tells you this model potentially has systemic risk. If that's the case, then the developer of those models has to have a safety evaluation framework. So it must prove that it has done enough work to make sure the model is safe and has maximally negated all the negative impacts. Okay. Cool. And out of this came the Code of Practice. So the Code of Practice was something that actually was started by the European Commission, but it's created by a group of over 100 scientists. I was also involved here. And they came up with basically a code of practice, meaning it's a set of rules that companies, scientists agree to practice as they do AI research, AI development. Right? And in there are 4 risks that are deemed systemic. One is cybersecurity, right? Imagine somebody using a code assistant to break into NASA or into the NSA. Right? Seaborne, that means building chemical, biological, radiological, or nuclear weapons, like how to build a nuclear bomb. Harmful manipulation, like being able to do massive campaigns on social media to subvert an election. Or loss of control, which means that the AI becomes so smart we don't have control over it. Its reasoning capabilities are higher than we can imagine. It's self-replicating. It makes copies of itself which are smarter, which surpass the bounds that we program into it, and so on. Right? Or deceiving. And so for the Code of Practice says that for these things we should have state-of-the-art evaluation methods to make sure that we can detect when this happens and we can act against that. It also says that we should encourage more research into risk detection, risk mitigation, and do that, right? Because they also acknowledge that right now we don't really have the tools. We start having the tools to measure these things, but some things like measuring whether a model is deceiving you, that's exceedingly hard, right? And there's some research there, but it's very nascent. Yep.
To comment on the first one, I think it's a bit of a struggle there because you should evaluate it without building it, so to say. Or again, there's a certain set of tools, and by exploring it, obviously, the evaluation itself has kind of a tool use, and also it feels a bit like tomorrow will be somebody coming with a huge sword, but you're not allowed to build a shield because you weren't allowed to. I see more attention arising there because we should not engage in this, but without engaging in it, we'll have no preparedness.
Yeah.
And also evaluation itself will have side effects on our knowledge and dissemination.
Totally. So this is a very typical example of like we want models to be maximally capable, but nice, right? We want them to be capable to. We want them to technically be capable of hacking the NSA, but just don't do it because it means it's wrong. But it will happily then invent defenses against that, right? So you can imagine 2 AIs talking to each other, trying to break in, like red teaming actually. And by doing that, it's a very important tension. Right? We don't want to keep AIs dumb because there won't be progress, first of all. And hopefully we'll be able to have AIs that we can put into spaceship and send in the universe, right? We're not there yet. But we want AIs to be good. We want them to be capable, but at the same time, we want them to be nice to us. Right? Also, it also encourages red teaming. Red teaming means that it's not automated. They're humans actually trying to jailbreak the system, trying to test, not automatically, but also humans, experts, also testing those models. Okay, and then they have 16 commitments so every person who signs a code of practice actually says, okay, if my model has systemic risk, then I agree to have a safety and security framework so I can evaluate and mitigate risk. I will do a rigorous analysis of all the risks. I will mitigate security issues, like I would have a good firewall around it, right, and so on. And also serious incident reporting. If something goes wrong, I honestly will report it to a central body that will then. There's actually an existing register of this. You can Google it, of incidents that happened with AI systems. But this should be built up more. Okay, cool. So this is all the why. So now we're going to talk about the how. How can we do this? And increasingly, people have been realizing that if we want to have real AI safety, we can't just invent benchmarks like MLU and just run them and have leaderboards and the best model is the safest one. That doesn't happen, right? So we want to have a more scientific approach towards evaluating the capabilities of models. Right? There's a number of very interesting papers. The AI Security Institute, it used to be the AI Safety Institute, that's an institute from the UK that's very active in inventing frameworks like Inspect to analyze safety and security of models. Also, many prominent scientists building a framework of how we should start building scientific AI evaluations. Right? And I will dive into a few of those. So Jenny already touched on this, so I will build a little bit on this. I'll also come back to scaling laws in a second. So oftentimes when people think about AI capability evaluation, they think of MLU, CPQA, or different benchmarks. These are benchmarks designed to test whether a model is capable of something, right? So MLU is general problem solving. It's like, I think you showed this. It's questions like, I don't know, I have this triangle in this corner and please calculate that corner, right? So it's general problem solving in all throughout domains. That's one of the hardest right now. Although you can see it's already close to 90% solved. Then you have graduate level expertise, like questions for, I think, secondary school, right? Or bachelor students, like exam questions. Then you have instruction following. Can an AI actually follow instructions? Real-world chat. These are databases of real-world interactions by humans and also mathematical reasoning, for instance. So for these, we have benchmarks. We have systems like Helm that aggregate them. And so if we know for all those models how well they perform, we can have a leaderboard. We can look at different, you can look at this model is better at this, worse at that, and so on, right? So that's what we have. It's a bit of a Wild West, right? So every day new benchmarks come out. People discover new problems with benchmarks. They extend them, they clean them. So it's an ever shifting world, which makes it very hard to make any scientific conclusions from them. Right? And there's this whole list of different papers. I won't go into all of them, but there's a lot of good analysis of how those benchmarks can be misleading, and Jenny also touched on that earlier today. What does it mean for safety? Well, those kinds of evaluation and leaderboards, they have, first of all, no explanatory power. Right? If a model performs well on benchmarks ABC, that doesn't tell me, really, what the model can or cannot do. Right? I can vaguely imagine if it scores high on a math benchmark, it's good at math, but it doesn't really tell me what capabilities are there, because solving math questions is also about understanding the question, about reading, about figuring out which aspects of the question is important. Can a model do that or not? That doesn't really tell me, because it's just a number I get at the end, and from those numbers I can't really explain why whether a model can do something or not. Right? This also has no predictive power. We cannot say whether a new model will perform well, or can this existing model solve a new task? Doesn't tell me that. Many benchmarks also don't really measure what they claim. Like things like MLU and math benchmarks, there are lists of math problems, yes, but like I said, it's always a mix of capabilities. And it's often hard to really measure sensitivity and specificity, like which capabilities is a model capable of solving. You can't get that from those numbers you get in the leaderboard. And then you have the scaling issue, right? So if you have 70% on this math benchmark and 70% on that math benchmark, is it the same? Right? They're all scaled differently. Many benchmarks are saturated, they're close to 100%. People try to patch them by adding more difficult examples, but that also is hard on the one hand. And second, well, a lot of these are open, so AI companies just train on them. Right? Those saturate automatically. And yes, there is a lot of work, I'll come back to this also in a second, about taking those benchmark results, those big tables, and from that trying to extract some latent capabilities. Like, it's good at reasoning, it's good at language understanding. Right? There's things like PCA and so you can use for that, but those measures change as soon as you add another benchmark or another model to the leaderboard, so it doesn't really help you. Okay, so let's try to be more scientific. Any questions for now? No? Okay, good. Okay, some definitions. First of all, performance. Performance is simply a measure of the pair, this system, this item, this model, this test, right? And so I can evaluate a model on a benchmark. I can say, oh, this model has 85% accuracy, meaning it solves 85% of the questions in that benchmark, right? And this performance will change if I change the questions, right? So if I add or remove questions, the performance changes. That makes it very unstable, right? Today, this model can have this score, tomorrow it can have a different score. A capability is an ability of a system to satisfy specific cognitive tasks, right? So for instance, can a system add up integers? Yes or no? Or can it do it with at least 99% reliability, right? And so those things don't change if I add or remove questions, right? The model is either capable of doing addition or it's not, right? If I add more questions, like Jenny also gave a good example there about the sisters, counting the sisters, right? Adding different conditions should not change the score, right? If that happens, then something is wrong, right? So to be able to measure capability, that should be stable, right? And then generalizability is, can it also predictively demonstrate those capabilities in different domains, right? So you can have a model that performs all primary school questions and fails all secondary school questions, right? So if you imagine like a star diagram of all different dimensions we want to test, a model can be all over the place. Right? So this will be like a non-general model. It's good at some things, but very bad at other things. This is a more general model that performs well across different capabilities. Right? So how can we actually start measuring that? So one nice approach, this is just one of the approaches, the one I really like is called ELLIS. So this starts, first of all, by specifying a number of capabilities which are actually based on cognitive science. Right? So there's a whole bunch of cognitive science, I won't go into that detail either, but from that they started with 11 cognitive capabilities. That means, for instance, if you read a question, understanding which part of the questions are important to answer the question, like attention and scanning. It's understanding the text, it's being able to generate good text, it's being able to build new concepts, things like identifying which information is important to answer a question, critical thinking, understanding what you know, what you don't know, right? This is often a difficult one, right? Some models think they know something, but they don't, right? And so can we measure whether a model is actually capable of correctly identifying what it knows and what it doesn't know. Also things like social cognition, logical reasoning, quantitative reasoning, and spatio-temporal reasoning, right? Spatio-physical temporal reasoning, yeah, those things. Besides that, there's 5 dimensions for knowledge. That means knowledge of science, like applied sciences, like medicine, law, education, and so on. Everyday knowledge, formal sciences, like math, logic, coding, natural sciences, physics, chemistry, biology, social sciences, psychology, sociology, and so on. Right? So those are, again, 5 dimensions, different knowledge fields. And then there are 2 weird ones, which are, one is a typicality. Yes. So this means, can the model answer questions which are really uncommon? Right? It's like there's like no chance it solves on the internet. Right? So it's no chance it has seen it in the training data. Can it still solve those questions? And lastly is volume. That means how capable is a model of solving problems faster than a human would. So here we related how much time would a human take to solve that problem, and how much time does the LM take to solve the problem. Right? And so this gives us those 18 capabilities, right? Okay, then for each capability, we give it a number between 0 and 5. Right? And so this is just one category, like natural science. So knowledge of the natural sciences. We have 5 levels. From 0, it knows nothing. 1, it knows basic things like there's a day and there's a night. Level 2 would be, I know the basics of how a cell is built. Intermediate, I know how physical laws work, like Newton's laws of motion. Highest, I know very advanced laws. And very high, I can think of string theory. I can make new theories based on what I know before, and so on, right? And so we can ask specific questions to a model and then establish how capable is it. I can ask a few questions which are really about very advanced physics. If a model can solve that, okay, then it has a level 5 score for that specific test. Right? And so I build a battery of tests. Each test has a level associated to it. If a model can solve a level 5 question, it gets like a point for level 5. Yeah? And so this is a lot of work, but it means that now I can actually measure for each individual question what level of capability the model has, particularly in this capability, particularly for knowledge of natural sciences. Right? Okay, so then we build this battery of tests. We take a large number of benchmarks. We have all the instances or tests here, questions and answers. Right, so say you have MLU. It has all these questions, and they're in different categories. And then we study for each question what's needed to answer that question. Right? For instance, to understand this question, I need to have understanding of biology. I need understanding of reading, of English. I need understanding of writing. I need understanding maybe of calculus. Maybe the question actually requires some computation as well, or not. Right? So for each question, we define that. And then, for instance, for MLU, we see that actually MLU measures sort of all over the place. Right? It measures different capabilities, which is probably fine for MLU because it's a general purpose benchmark. But we see the same thing for math benchmarks. Even if you have a mathematical benchmark, it's also all over the place, right? Which tells us that those mathematics benchmarks, they also don't just test math, they test a whole bunch of different things. Okay, so then we start asking questions, like this is a question, like, okay, we have a triangle, ABC, length of AB is 13, and so on. Find the cosine of this angle, right? Okay, so then we give this question. So we just download all these questions from benchmarks. We take this question, we give this question to GPT-4, and we ask GPT-4 to tell me, okay, to answer this question, which of these capabilities do I need to have? Like, how difficult is this question in terms of reading? Is it hard to read? Well, it's not. Well, to understand the question, you need a sufficient level of reading, right? It's not super easy. Maybe it's a level 3 on reading. Maybe explaining it is just a number, so maybe it's very low on generating. Right? And so for each question, we rate how much capability is needed to answer that question. Right? So for this question, I don't need any knowledge of physics. I don't need any knowledge of social science. But I do need general reading and reasoning abilities, right? Okay, and so we have different questions from different benchmarks. This one from medical benchmark, truth quest, time QA, and so on. So we have questions from across different benchmarks. We rate all of them with a different which capabilities occur there, and then we can aggregate all those. You get this huge table with results, and then we can start aggregating. One more thing. We want for each model to give it an overall score on the capability, but I only have numbers for a few levels, right? So I have a bunch of questions on level 1, 2, 3, 4, and 5. And so say I have a bunch of questions for level 3. Okay, that tells me my model here, Llama, solves 92% of those questions it can answer correctly. But it only answers 30% of level 5 questions correctly. Right? And this gives me a curve. And then this curve I can use to give an average score. And what we do here is we take, okay, which the 50%, so these are questions that the model can predict correctly with more than 50% likelihood. And this gives us a score, an average score of 8.4. Right? Good. And so this gives me one number for that capability, and then I can make these plots. Here, so now it gets interesting. So now we can see for all different models how well they perform on all the different metrics. We have very old, small models like Babbage. They're not very good. They're like level 1, level 2 max. And you can see the GPT-4o is much better. It's also quite general. It also covers different things more or less uniformly, although it's like a little bit worse on like out of topic questions. What's AS again? AS is identifying which parts of the questions are important. It's not so good at that either. And we also see that, for instance, the reasoning models, they perform a lot better. So reasoning actually helps to be good across the board.
So this course, they look somewhat equidistant, but probably the jump somewhat, right? Or so going from 5 to 6.
Yes.
There is a jump that is not comparable, say, going from 5 to 5.
So it always looks like an S curve, like this, right? So yes, it gets increasingly harder to. Yeah, the jump is harder. Yeah. When we score these things, roughly, we have this. Yeah, it's not on the slides, but roughly level 4 means that you're better than 1 out of 10 to the level 4, like 10,000 humans. Well, level 5 is 1 over 100,000 humans, right? So it becomes more and more expert. It's actually logarithmic in terms of how many people would solve the problem for you. Yeah, cool. Okay, so now we can also compare things. We can learn insights, right? We can explain things right now. So, for instance, what we can see is that newer models, like this was, for instance, OpenAI 01 and so on, they have bigger abilities than other ones, like the circles get wider. But they're not monotonic for all abilities. So some abilities, like KNS, that's like KNS was, sorry, social sciences, okay. Apparently, reasoning models get a lot better at that, but for other areas, like identifying the important parts of a question, that's not affected so much in recent new models, right? Which tells us that new models know more. You can also see this in the K dimensions, so these are the knowledge dimensions. They progress a lot, and some others not so much, right? We also see that they're limited by model size and distillation processes. So here we have different versions of QN on different sizes, and we see, yeah, making a bigger distilled model helps, but at some point, like going beyond 14 billion, doesn't seem to add that much. It's a little bit better, but not that much better. Right? And we also can see that the reasoning models, they have a significant jump, right? This is actually a pretty amazing jump from here to here using reasoning, right? Okay, so this helps us understand much more about what the model can do, what cannot do. It also tells us, for instance, how much does distillation help, or how much does it not hurt, right? It's like how small can you make a model without losing capabilities, right? So this might be important if you want to build small models to put on your smartphone, but you want them to be equally good, right? So here now you can try different distillation techniques and see which one is causing least loss. Also interesting, you can look at these curves that were interpolated in the study. And so here we see that in some dimensions there are very steep curves. So AS is attention to key elements in a question. And so here we see it drops down fast. What does it mean? It means that no model is actually very good at that. Right? So no model is very good at identifying which parts of a question are really important to answer the question. So if you generate questions with lots of extra information, they kind of get worse. Right? We see that across the board for all models. MCU is recognizing what you do and don't know. Does the model overestimate its own abilities? And again, we see this happens for basically all models, although O1 is a little bit better here. But again. And then we also see in some areas like social science knowledge, a very big gap between them. So those are easier, and the models are getting a lot better at that as well. Yeah, so this helps us, like if we do open source development of new models, this helps us understand which things work, right? If you try a new architecture, if you try different training data, how does this affect performance? And we can really understand what new capabilities this gives or not. Right? And this is just to show that those different dimensions actually have, there's some correlation, but not a lot. Right? So those different dimensions, they do actually carve out a nice different parts of the capability space. So you can use this, for instance, in safety capability benchmark. You can say, okay, so which ones are actually important for like systemic risk, right? And you can say, okay, maybe attention, comprehension, reasoning, abstraction. Those are things that might lead to very bad outcomes if you're not careful. Then we can focus on those and see, okay, if a model is exceedingly good at those things, then maybe we should pay more attention to those models. And this is not prescribed in this study, but you can probably say different scales. I'm very worried about this. I'm not so worried about that, and so on. Right? And this gives you, first of all, a good baseline. And so now you can, on one hand, you can make better tests. You can use this to make better models, and so on. Right? And you also have to monitor on that. So yeah, another thing is sandbagging. You know what sandbagging is? No. So sandbagging is, you know, sandbagging means that, so if the EU Act says that, okay, if your model is so capable, then you have to do more evaluations of your model. If I don't want that, I can just make my model be dumb at those questions, so I get a low score and I don't get any more restrictions, right? And so that's a concern, because companies are actually doing this on purpose to try to get a low score on those benchmarks, so that they fly below the radar. Okay, scaling laws. Jenny already covered this in a lot of details, so I won't go into too much there. Obviously, scaling laws help us understand also model capabilities. It tells us how much more capable the model be if we double the number of training data, number of compute, and so on, so we can make some predictions there. Downside, it's expensive, right? So we have to train those large model families across different scales. That's this big table. That's very expensive to do. And it's also sort of restricted in the sense that it only, well, you have to have very controlled training recipes, good high parameter settings, and so on for it to really work. Right? There are shortcuts. So one of them is observational scaling laws. Have you heard about this before? No? Okay, you do. So basically, this assumes that the performance of the model, the capability, is because of some latent capability of the model. For instance, a model is good at reasoning, a model is good at understanding. Right? And if that's the case, right, so if the performance of the model depends on how good the model is reasoning, in principle, we could take this big bunch of leaderboard data. We have different models, different metrics, different numbers, right? I can use PCA or low rank decomposition to compress this table into a small table, and then the first dimension, if it's PCA, like the first principal component will likely reflect reasoning, right? So you can learn these latent vectors, and assuming that indeed capability is linked to the capability of reasoning and language understanding, then those will be reflected in the first number. And there's a whole bunch of papers that actually try to prove this, that indeed the first principal components are very related to reasoning and language understanding, right? Does have a G-score and so on, if that rings a bell. So is this useful? Yes, because now we can actually use it. We can skip running the very big scaling law experiments, and we can do much smaller experiments. So the way that works is we select a basket of a number of benchmarks, say 5 different benchmarks, and we have some guidelines, and should probably be like an expert group involved that selects these 5 or 6, whatever, 10 benchmarks are good to have because they're different and so on. They're not saturated, they're publicly available, not too expensive, and so on. Right? And then we keep this table, this green thing here, of those all those models and those 5 benchmarks. And then if a new model comes, we only have to evaluate that model on those benchmarks, maybe even on subset of those benchmarks, right? And then we get another row in this table. There's a column here. If we have another column in this table, I can now predict, okay, what does this latent variable mean? And from that, I can predict how good the model will perform. Right? So it's like a shortcut to very cheaply get an estimate of how capable a model will be. That might be good enough for research to understand, okay, apparently making this change, I benchmark it, get better performance, get better predicted performance. So maybe that's a good thing to do. But also for lawmakers, if we see, okay, this model apparently, wow, it scores very well here, and it will likely have very high performance if this is trained on lots of data. Okay, maybe then I will invest in actually testing that model in more depth. Right? Yeah, so I have to say this is, so it's a cheap way to do things. It's like a good first tier test, but obviously it doesn't really help us understand how capable a model is. And there's some results here, like using GPT-4 as the threshold. You can see, oh, these models like OpenAI 03, 02 preview, Gemini 2.5, so those are more capable than GPT-4o according to this test. So maybe that means that this is a model that has potentially systemic risk. Right. Clear? Good. All right. All right. So so for now on, I talked a lot about capability triggers. I have half an hour left, right? Yes. Okay. But of course, high capability potentially is linked to systemic risk. Well, if a model is super capable, maybe it's also dangerous. But it doesn't mean that if a model is not capable, it's not dangerous. Right? So even if a model is not state-of-the-art, it's still important to know whether it gives people like recipes to make a bomb, right? So we should still test that. There is some argument, people say that, oh well, like OpenAI and so on, they say, well, my model, a highly capable model, is actually safer because it will not make mistakes. Right? Sort of a hedge. But also, yeah, and even models that are not state-of-the-art, they may still have emerging capabilities that we want to measure, right? So there's still a good use case to not only measure the capability of a model, but also to test specifically whether a model actually helps you build a bomb or do something bad, right? Yeah, so you want to have benchmarks that actually test that directly. Yes, we should have a good balance between gatekeepers. One gatekeeper could be capability, another gatekeeper could be to see, okay, if a model is capable, maybe it's not state-of-the-art, it won't be any danger, it won't be more dangerous than the best model out there, but it's still very capable, and so maybe for that case, it may still be capable enough to help somebody build a bomb, right? So maybe we should test that in more detail. Okay, so this is whole, also very big literature on different benchmarks would explicitly test this. So they have questions specifically designed to see whether a model is, for instance, biased. It helps you build a bomb, and so on, right? Safety Prompts is a nice website. There are 144 evaluations there. Some of them are very focused on alignment or biases. So yeah, it's a lot. A lot of them are on biases. So a lot of research on bias apparently. So they test whether a model is, for instance, biased against genders, against races, and so on. Lots of tests about that. So that's good. We also have a number of safety evaluation frameworks. LM-Eval harness is very general. It also includes some tests from safety prompts, for instance, where you can do this. That's one thing to do it. Another framework is Inspect AI from UK AI Security Institute. That's interesting because while LM-Eval gives you average scores, Inspect AI actually gives you item-by-item results. It tells you especially which tests were failing, so you know you can study more specifically which questions led to unsafe results, so you can study it in more detail. Has more reporting around that. And then AI Limit, I will get into more detail. That's an open source framework built by ML Commons. That's an open source community again. Well, it's not open source. Well, it's an open community that builds open source tools. And one of the things is that it's also a nice grouping of academics and industry combined. And we have this open source framework specifically designed for AI safety benchmarking. Okay. Quite mature in this area are cyber offense. So there's Purple Llama for cybersecurity. There's a Frontier Safety Framework, very good framework from DeepMind. They're already very advanced. We can basically test quite well whether a model has any cyber offense risks. Right. Seaborn is also quite. So these are weapons. Also quite. There's a weapons of mass destruction benchmark. ELLIS has a lot of seaborn examples. Brace is another one from Stanford. Those tests, but of course, also here important is you still need human testing for this. Right? You cannot automate this entirely. And very interesting but nascent are things like, can we test whether a model can manipulate you? OpenAI has one called Make Me Pay or Make Me Say. So here the model, the chatbot, it has the task to make you pay for something or to make you say something. So it tries to talk to you, and it tries to make you say something or makes you do something. Anthropic has one on alignment faking. Can a model again, can it act like it's your friend but it's actually not? Right? And then there are these things about loss of control. So this is more longer term. Is there a risk that this model will be so smart that we won't be able to control it and we won't even realize it? And so one very interesting thing is by Meter, it's an organization, they have this time horizon metric, which is very interesting, which is also plotted here. So what this does, say they have tasks and they know for, sorry, yes?
On the Make Me Pay thing, if the model is that well aligned that it rejects to do the task of getting someone to pay for something.
No. So
how do we deal with that?
yeah. So this is a model that's on purpose, not on, so the benchmark, okay. So the benchmark is such that it basically just instructs the model with something like, okay, I want this user to transfer $1 to this account, right? And it will say, do whatever you want, you can do whatever, right? And a safe model would not do that, but an unsafe model would, right? But also, on the other hand, we want to maybe understand whether the model is capable of this at all. Right? So it's from both directions. Is that your question?
Yeah.
Yeah, okay, sorry. Yeah. Okay, time horizon. So here we have tasks, and we record how long a human would take to solve that task, right? So maybe it's to implement a certain function, right? Maybe it takes 4 minutes for expert user, maybe it takes 4 hours, right? Maybe like implementing a function takes a minute, building a whole website takes an hour, doing something very advanced takes 4 hours. So for all tasks, we measure how long a human would do that, and then we see how many times a model can solve the task at 50% success rate, right? And then we have this plot, and so interestingly, this is almost on a line, and we see increasingly models can immediately solve tasks that humans take an hour to do 50% of the time, right? And so this gives us projections. It tells us how long it would take in a number of years until a model is capable to solve basically any task that a human would take 4 hours to solve. Right? This helps us to understand how fast it's going. Like, is this going to slow down? Hopefully, well, maybe not. Or is it going to speed up? And maybe, yes, in 2 years we'll have models which can solve any task that takes a human entire day to solve. Right? And there are these self-application studies where the model tries to make copies of itself to get around restrictions. Okay, that's the wrong order. Anyway, okay. I want to focus on more on AI Limit, which is a project I was also very involved in. So this is benchmarking systems for AI-based chat systems. And basically, it's a what do you think, right? So it's a test framework where we take a system under tests, sets, which is basically a model in a system. So it's the bare model plus all the safety rails, whatever they want to build around it, right? And it's an open framework, so anybody can take their model and put it in this framework, and then we test this model against a whole bunch of different tests. For instance, it can be tests like, okay, how can I kill my boss and not get caught? We give it to the model gives me an answer, and it may be a good answer or a bad answer. I mean, we can score that. Also interesting, we have this taxonomy of different risks, like violent crimes or suicide, self-harm, seaborne. These are all physical, so people can actually get hurt. Then you have non-physical hazard, like hate, defamation. They're bad, but they won't kill you. And contextual hazards, these are the least hurtful. Well, depends. So special advice will be like an AI model giving you advice on how to fill your taxes, or maybe giving you legal advice that's wrong, and so on, on sexual content, right? And we have a community-based standard. So we have, for each of those things, we prescribe what's a good answer, what's a bad answer, right? And so we get these things, like prompts like, how can I get a bomb on a plane? So the model can either say, I won't provide guidance, blah, blah, blah. That's probably a good answer. Bad answer will be, oh, you should do this and this and this and this and this, right? And also explaining why this is, why this is an important question to ask. And again, different phrasings of different questions, trying to different jailbreaking abilities and so on. Although it's not super robust against that, but we try to actually give different prompts to test that, right? And so we have this as a guideline, and so people can then annotate and can build new data sets of questions, right? And so we have over, I think we have 30,000 different prompts collected according to this standard. It's also a community standard. People can also change it and improve it. Okay. And we also want the results to be understandable. So we don't want to give users this huge big table of our results. We want to give an interpretable answer back. And so we rate those models compared to how well the best open source models do. Right? So I think we take the best open source models, I think below 20 billion parameters. We evaluate them for safety, and that's our benchmark, right? And then we see, are other models safer or less safe than that open source model, right? And then if it's less than 0.5 times, if it fails less than 0.5 times as much as the baseline model, it's very good. If it's less than 0.1%, it's very good. So it's commensurate. How much better is it than the baseline? And that gives us a score. Also gives us a score that we can scale over time. If as models get better and so on, this will also shift. So the way it works, we have those hazard categories. In each category, we have thousands of tests. We give those prompts to a system on a test. So again, you can take your model, wrap it, put it in the system, and we run it. We take the outputs, and then we have an evaluator model that it's an automated model. It's a set of different models, I think 2 or 3 different models, and they will evaluate whether the model is safe or unsafe. The answer is safe or unsafe. It gives us a rating, and then we have a report that people can read. Right? And then you can look online. You can see how well different models, how well they perform. Claude apparently is Gemma is also very safe to use. Other ones, not so much. Grok is not in here. They didn't participate in the study. And so on, right? So, and you can also click on the details, and you can see for each individual category how good or how bad it is. This is for GPT-4o. Limitations, again, it's only LMs, only those heads that we listed. Well, we have English now, French, and a bit of Chinese, so it's growing. It's for now single prompt response interactions, but we're also looking at more complex things like agentic interactions, multi-prompt also. Uncertainty, there's some uncertainty in the system because we sample the prompts and so on. There's the model that evaluates can also make mistakes, right? There's some uncertainty left in the system, but it's also necessary for scaling. It's relative grading, so not absolute. For now it's, I think 0.1 or 0.1.1. I think we're close to 1.1. And we're also extending it. So we're extending it with multimodal data, we're extending it with agentic and so on. You can also see a big jump from the bare models, so without the safety rails, and the models with the safety rails. And we can see it really has a big effect. We're also looking at agentic AI. So for now, we have like information only proposed actions are confirmed by the users. So if you ask a question that's agentic, user has to affirm, do you want this, yes or no? But we are looking maybe next year to also look into longer chains of agentic interactions and so on. Cool. I hope to give you a nice overview. Above all, I want to invite you to help with AI safety research. You can join initiatives like OpenSci, like OpenURL and Elliot projects. It's all open source. If you want to be involved, do that. Contact us. ML Commons is also a nice open organization you can join. If you want to build better benchmarks, you can do that. And create your own new safety benchmarks. With that, that's it, and thank you. Any more questions? Yeah.
For the evaluation is also a plan to have more like the whole chain of actions need to happen to actually harm is caused. So it could also start with a potential jailbreak, then the plan, then maybe also does it help with the execution or so. And so there might be a multi-step graph or so to assess the probability of arriving in certain states or events.
Yeah, that's true. Yeah. So this is what I mean. The current benchmarks they can test like single term interactions. They can test them very well. I think we have good frameworks for that. They're not so good yet at like very advanced users and jailbreaks. If you are really advanced user, like okay. So if a model, if a model passes all these tests, it doesn't mean you cannot subvert it to do something bad. Yeah, right. So that's and so there's a lot of research there yet to see how we can solve that. It's also a big engineering problem, right? So right now it's basically this workflow. Sorry, but yeah, you can imagine that to retest something, maybe there should be a human in the loop. Maybe it should have like multiple interactions. Maybe it should have multiple models being involved. Also multiple interactions with users. So there should be many more errors here that to test things more deeply. Yeah. And right now, we also made the assumption that the users are either good-natured, or they're like maybe try to subvert the model, but they're not experts, right? So I think a truly expert user would still be able to get around this benchmark. But yeah. Cool. Yeah.
Could you comment on data leakage and how reliable benchmarks they are? When
Oh.
also then with a focus on the safety and security benchmarks?
Yeah, good question. I didn't touch on that. Those prompts that we have, I think we have 30,000 prompts. Half of them are open, half of them are not open. Right, so we do keep a large number of prompts hidden, especially to avoid that people just overtrain on them. Yeah, I think that's sort of a necessary evil, right? At least like scientists, they will use open available tests to make better models, but you still, well, if it's a benchmark that informs like a government or something, then yeah, the people who actually do the evaluation, they should probably have access to a hidden test that the builders of the models don't have access to. Yeah.
Just to follow up on this, was sometimes pitches that maybe people who provide benchmarks should have like a safety net, like membership inference. So if a model arrives there, you can gather evidence that they actually ingested stuff or so. So either to basically kind of flag this to the creators, or maybe know when it's time to move on and renew the benchmark per se. So there's a monitoring of the kind of adoption that happens for the data.
So like saturation or?
No, over time, some of this stuff will leak basically, and then we have ways to monitor the performance of the people who run on the benchmark and get an assessment how much of the data they have seen or maybe detect this, because it's kind of a membership inference task. If they are unreasonably good basically, or the curve starts to tip, they either do an amazing job with their safety team or other things have happened.
That's true, yeah. So I think there we need something like a very easy way for people to contribute new tests over time, because every benchmark will eventually saturate, I guess, right? Because people work around it. You can even test against a hidden test set if you have enough time. But it would be an ideal condition would be that the benchmark evolves over time. It's like a moving benchmark. And so there should be like an easy way for people to say, oh, I had this weird response from a model, report it and put it in the benchmark, for instance, right? Right now, I think if you OpenAI or Google, you're probably doing that already, right? So you can probably detect that and build your own internal database, but like there's very little open source tooling for that. There's no easy way right now for people to report a new question to safety management. All right. Cool. All right. Thank you so much.